identify the least negative value. So the least negative value here is -5. So therefore this is called our incoming variables, incoming row. The objective function is found to be max z is equal to 5x1 minus 6x2 minus 7x3 plus 0s1 plus 0s2 plus 0s3. The initial cost of s1, s2 and s3 are found to be 0. The intersection of outgoing and incoming variable is called the key value. This is called as the key value. Hello dear students, welcome to this session of OR class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in the previous class I have discussed regarding a problem based on a Simplex method, solving a linear programming problem using Simplex method. Today also I am going to take one more example of Simplex method. Now let us take this example. Solve the following linear programming problem using Simplex method. So what is the objective function? Max z, this is maximization. Max z is equal to 5x1 minus 6x2 minus 7x3 subjected to the constraints. What are the constraints? x1 plus 5x2 minus 3x3 is less than or equal to 15. 5x1 plus 6x2 plus 10x3 is less than or equal to 20. And x1 plus x2 plus x3 is less than or equal to 5. Where x1, x2 and x3 is greater than or equal to 0. That is all positive restrictions. Now, let us consider this is of maximization type. Now, let us convert the constraints less than or equal to equal to just by converting the inequalities into equalities. So, just we can write these equations as x1 plus 5x2 minus 3x2 is equal to 15, 5x1 plus 6x2 plus 10x3 is equal to 20, x1 plus x2 plus x3 is equal to 5. Since there are three variables x1, x2 and x3, now we are going to introduce the slack variables s1, s2 and s3. Now just introduce the slack variables s1 and s2 and s3 whose initial cost, the initial cost of s1, s2 and s3 is 0. Now therefore, the standard form of this equation can be written as, standard form is maximum z is equal to 5x1 minus 6x2 minus 7x3. We are introducing the slack variables, that is 0s1 plus 0s2 plus 0s3. So this is the objective function. So the coefficient of s1, s2, s3 is 0, 0, 0. Now the constraints are x1 plus 5x2 minus 3x3 plus s1 is equal to 15. The first equation. For the second equation, 5x1 plus 6x2 plus 10x3 plus another slack variable s2 is equal to 20. Now, whereas the last equation x1 plus x2 plus x3 plus s3 is equal to 5, where x1 comma x2 comma x3, s1 comma s2 comma s3 are all greater than or equal to 0, non-negative restrictions. So that is the standard form of the given equation. So just for the given equation, add the slack variables s1, s2 and s3. The objective function is found to be max z is equal to 5x1 minus 6x2 minus 7x3 plus 0s1 plus 0s2 plus 0s3. The initial cost of s1, s2 and s3 are found to be 0. Now the constraints will change as to x1 plus 5x2 minus 3x3 plus s1 is equal to 15. 5x1 plus 6x2 plus 10x3 plus s2 is equal to 20, and x1 plus x2 plus x3 plus s3 is equal to 5, and the values x1, x2, x3, s1, s2, s3 are all greater than or equal to 0, the non-negative restriction. Now based on this, let us construct the initial simplex table. Now before that, write down the coefficients of all these x1, coefficient of x1, x2, x3, and similarly s1, s2 and S3. So for the first equation, the coefficient for these three equations, the coefficients are 1, 5, minus 3. Then S1 is 1, S2 is 0, S3 is also 0. For the second equation, the coefficient of x1 is 5, x2 is 6, x3 is 10, and S1 is 0, S2 coefficient is 1, S3 is not there, 0. For the third equation, it is 1, 1, 1, and the coefficient of S1 is 0, S2 is 0, and S3 is 1. So therefore, this will form an identity matrix of order 3 rows 3 column. This is an identity matrix of order 3 rows 3 columns. So what are the values? S1, S2 and S3, 1, 0, 0, 0, 1, 0, 0, 0, 1. So this will form an identity matrix. Now the initial simplex table. Now I will go to the next page. The initial simplex table will be, so you know how to construct the initial simplex table. So in the first row, the initial vectors are coefficient of basic vectors, basic values that is C, J, and the coefficients of the objective function. So x1, x2, x3, s1, s2, s3, the ratios and the x0 value. So here s1, s2 and s3 form an identity vector. Therefore, the values of s1, s2 and s3 are taken here, s1, s2 and s3. The initial cost of s1, s2 and s3 is 0, 0 and 0. s1 is 0, s2 is also 0, s3 is also 0. Zj, and the last column contains delta j is equal to Zj minus Cj. Now, here x0, x1, x2, x3, s1, s2, s3 and the ratios. Write down the coefficients of x1, x2, x3, s1, s2, s3 from the three constraints, from the three equations. So the coefficients are nothing but these are the coefficients. That's it. So I will put it in the table. The coefficient of x1, before that the objective function, the values of x1, x2, x3, coefficient of x1, x2, x3 in the objective function is, coefficient of x1 is 5, x2 is minus 6, x3 is minus 7, and s1 is 0, s2 is 0 and s3 is also equal to 0. Now write down the coefficients of the constraints. For the first equation, it is 1, 5 and minus 3, 1, 5, minus 3, whereas s1 is 1, 0 and 0. Similarly, for the second equation, 5, 6, 10, 5, 6, 10, 0, 1, 0, 5, 6, 10, 0, 1, 0. And similarly, for the third equation, it is 1, 1, 1, 0, 0, 1. So 1, 1, 1, 0, 0, 1. And the values of x0 are nothing but this is 15, 20 and 5. 15, then 20 and 5. So just fill this table, that is the coefficients of x0, x1, x2, x3, s1, s2, s3 from the objective function and the constraints. Okay. Now let us find out the value of Zj. Okay. Now find out the value of Zj. So here Zj is equal to, just multiply this. So multiplying with this, so 0 into 15 plus 0 into 20 plus 0 into 5. So this is equal to 0. Here it is 0. Next again 0 into 1, 0 into 1 plus 0 into 5 plus 0 into 1, 0 into 5 plus 0 into 1. Again this is also equal to 0. Similarly 0 into 5 is 0, 0 into 6 is 0, plus 0 into 1 is 0, this is also 0. Again 0 into minus 3 is 0, plus 0 into 10 is 0, plus 0 into 1 is 0, this is also again 0. Again 0 into 1 is 0, plus 0 into 0, plus 0 into, so this is also equal to 0. So again the last 0 into 0 plus 0 into 1 is 0, plus, so this is also 0 and this is also 0. So usually in the initial simplex table the value of Zj is always 0, 0, 0. Now find out the value of delta j is equal to Zj minus Cj. Delta j, what is delta j? Zj minus Cj. So first value, so this is 0 minus x0, 0 minus x1, that is 0 minus 5. 0 minus 5 is equal to minus 5. Again 0 minus of minus 6. 0 plus 6 is equal to, this is plus 6. Again 0 minus of minus 7. This is 0 plus 7 is equal to 7. This is plus 7. Again 0 minus 0 is 0. 0 minus 0 is 0 and 0 minus 0 is 0. So this is the initial simplex table. Okay, listen, find out delta j. Delta j is just cross multiply these two elements and add. Usually in the initial simplex table, the zj values are all found to be 0. Now find out delta j. Delta j is equal to zj minus cj. That is zj minus cj is nothing but 0 minus 5 is minus 5. 0 minus into minus is plus 6. 0 minus into minus is plus 7. So minus 5 plus 6 plus 7 and 0, 0 and 0. Now here in this row, in the delta j row, in the last row, identify the least negative value. So the least negative value here is minus 5. So therefore this is called our incoming variables, incoming row, that is incoming column. This is called an incoming column. So in delta j, identify the least negative element, least negative here. So and represent that particular column as incoming column. So here minus 5 is the least element, least negative. Therefore this is the incoming variable. This is the incoming variable. So incoming variables. So here this x1 is the incoming variable. Now find out the ratio. What is the ratio? So the ratio is found to be, the ratio is given by, the ratios are, so here this is called the key column, and just divide x0, all the elements of x0 by x1. So the ratio is x0 divided by x1. Divide all the elements. So this by x1. So x0 divided by x1. That is 15 by 1 is equal to 15. Next 20 divided by 5. 20 by 5 is 4. Again 5 divided by 1. 5 divided by 1 is equal to 5. So in the last column we are getting ratios as 15, 4 and 5. Now identify the least positive. The least positive is 4. This is the least positive. So therefore this row is called the outgoing row. This is called outgoing. Outgoing. So here S2 is outgoing and x1 is incoming variable. So this is very important step. So identify the least negative in the delta j column, in the delta j row. So here minus 5 is the least negative. This will represent the incoming variables, and find out the ratios. The ratios are given by x0 divided by x1. Divide all the elements of x0 by the elements of x1, key column. So 15 by 1 is 15, 20 by 5 is 4, 5 by 1 is 5. So 15, 4 and 5 are the ratios. Identify the least positive ratio here. The least positive is 4. Therefore this row is called the outgoing row and this is the incoming column. So the intersection of outgoing and incoming variable is called the key value. This is called as the key value. Here the key value is 5. The key value is 5. So and the key row is S1 and the key column is x1. So in the next initial simplex table, in the first iteration, this x1 is x1, that means S2 is replaced by x1. S1 is same and x2 is replaced by x1 and S3 will remain the same. And the second step is just convert this key element as 1. Now the first important point to be observed is convert this 5 into 1. So how to convert this element 5 as 1? Divide this entire row by the key element. What is the key element? 5 is the key element. So divide this S2 row by 5 so that this will reduce us to 1, and convert the remaining two elements, one as 0 and one as 0. Since these are 1 and 1, you can easily convert by using the elementary row operations R1 minus R2 or R1 minus R3 or R2 minus R1. So depending upon the elements, we can use the row operation to convert the remaining R1 element of this key as 0 and R3 element of this key as 0. Okay, now I will go to the next table. This is the first iteration table. Here the same initial vectors, coefficients of basic vectors, then x0, x1, x2, x3, s1, s2, s3. The values of x1, x2, x3 coefficients are same. Coefficient of x1 is 5, x2 is minus 6, x3 is minus 7, s1 is 0, s2 is 0 and s3 is also 0. The first row is same, and whereas s1 is the initial value of s1 is 0, s3 is also 0, whereas s2 is replaced by, see, this S2 outgoing is replaced by the incoming. This is x1 and the coefficient of x1 is 5. So therefore x1 and 5. Followed. This is very important. So the x2 is replaced by x1. So the coefficient of x1 is 5 and coefficient of s1 is 0 and s3 is 0 as it is. Now find out the values. Now as I told, so let us convert this element as 5. Now that means R2 dash is equal to, the first here is R2 dash is equal to R2 divided by 5. That means divide this all the elements 25, 6, I'll write here 25, 6, 25, 6, 10, 0, 10, 0, again 1, 0. Divide each and every element by 5. So if you divide by 5, so what you will get? This is 20 by 5 is 4, 5 by 5 is 1, this is 6 by 5, 10 by 5 is nothing but 2, 0 by 5 is 0, 1 by 5 and 0. So just divide each and every element of R2 by 5, the key element, then we are going to get 4, 1, 6 by 5, 2, 0, 1 by 5 as the new row 2. The new row 2 R2 is, here it is 4, 1, 6 by 5, 2, 0, 0, 1 by 5 and 0. Okay, this is R2. Let us convert this element as 0. To convert this element as 0, now I am going to perform the row operation. So here let us write R3 dash is equal to R3 minus R1 it is. Now what is the elements of R3? In the initial simplex table we have these elements as row R3, that is, let us consider the coefficients of x1. So that is 1, 1, 1, 0, 0, 1. I will write here 1, 1, 1, 1, 1, 1, 1, 1 again, then 0, yes, 0, 0, 1, 0, 0, 1. This is R3. Okay. Now write down the elements of R1, that is from the first iteration. What are R1? We have 1, 6 by 5, that is 1, 6 by 5, comma 2, 0, 2, 0, again 1 by 5 and 0. Okay, see here, this is R1, this is R1 from the new, that is new. Now subtract these two. If you subtract these two, that is R3 dash is equal to R3 minus R1. 1 minus 1, 0. This is 1 minus 6 by 5, 1 minus 2, then 0 minus 0, 0 minus 1 by 5, 1 minus, so this is 0, 5 ones are 5, this is minus 1 by 5 it is, then minus 1, 0, minus 1 by 5 and 1. So I will write here, this is 0, then minus 1 by 5, minus 1 by 5, then minus 1, 0, minus 1, 0, again minus 1 by 5 and 1, minus 1 by 5 and 1. So these are the values of S3. Okay. So if you want x0, x0 can also be written as, yes, 5 minus 4, it is 1. Okay. Now, so in the simplex table, we have 5 and 5 minus 4 is 1. 1 minus 1, 0, minus 1 by 5, minus 1, 0, minus 1 by 5 and 1. That is for S3. S3 row is concerned. Now, again convert this element as 0. Convert this element as 0. For this, we are going to use the same formation. That is same row operation. Okay. Now, again, to convert this element as 0, we will go for further row operation, that is R2 minus R1. So, I will write here. Now, again R2 minus R1. R1 dash is equal to R2 minus R1. What is R2? So, we have R2 as this 4, 1, 4, 1, 6 by 5, 6 by 5, comma 2, 0, 1 by 5, 4, 1, 6 by 5, 2, 0, 2, 0, 1 by 5 and 0. This is R2. This is R2. Now, what is R1? We have R1 as 15, 1, 5, 15, 1, 5, see here 15, 1, 5, minus 3, 1, 0, 0, minus 3, 1, 0, 0. This is R1. Subtract these two. What is the operation? Minus, subtract this. R1 dash is equal to R2 minus R1. 4 minus 15 is minus 9. 1 minus 1 is 0. 6 by 5 minus 5. This is 2 minus into minus plus 3. 0 minus 1. 1 by 5 minus 0 and 0 minus 0 is 0. So this is minus 9, 0. Take LCM, 5 is LCM. 5 5s are 25. 6 minus 25 is minus 19 by 5. This is 5 minus 1, 1 by 5 and 0. Substitute here. So the values are minus 9, 0, minus 19 by 5, 5, minus 1, 1 by 5 and 0. Now I will substitute here. Minus 9, 0. This is minus 9, 0. Minus 19 by 5, minus 19 by 5, again 5, minus 1 and 1 by 5 and 0. So these are the values. See here. So in this table, the key element becomes 1 and all the elements above and below the key elements are 0. So it is 0 and this is 0. Now just find out the value of delta j. Delta j is as usual. So this is 0 into 9. Before delta j, find out zj. Zj is equal to 0 into minus 9 plus 5 into 4 plus 0 into 1. So this is equal to 0. 5 4s are 20 plus 0 is equal to 20. So this is equal to 20. Now for this element, 0 into 0, 0 into 0 plus 5 into 1 plus 0 into 0. So what is this equal to? 5 into 1 is 5, remaining elements are 0. Again 0 into 19 by 5, this element 0 into 19 by 5 is 0 plus 5 gets cancelled, 5 into 6 by 5 plus 0 into minus 1 by 5 is 0. Here 5 gets cancelled, this is 6. Again 0 into 2 plus, see, this is 0 into 5 is 0, 5 into 2 is 10, 0 into minus 1 is 0, this is 10. Again 0 into 1 is 0, 5 into 0, 0, this is totally 0. Again 0 into 1 by 5 is 0, 5 and 5 gets cancelled, 1 plus 0 is 1. again 0 into 0, 0, 5 into 0, this is again 0. Okay. Now find out the value of delta j. Delta j is equal to zj minus cj. So what is zj minus cj? This is zj minus cj. 5 minus 5 is 0. 6 minus into minus plus, this is 12. Again 10 minus of minus c is plus 7. 10 plus 7 is 17. 0 minus 0 is 0. 1 minus 0 is 1. Again 0 minus 0. See here, in delta j column, all the values are greater than or equal to 0. So this is positive. All the elements, all the values are positive. Since all the elements, all the values of delta j are positive, hence the optimality is reached. Optimality is reached. So here the optimality is reached. Since all the values in delta j column, delta j row are positive, hence the optimality is reached. Hence we got the optimal solution at this point for the value of x1. x1 value is equal to 4. S1 is not here 0 and x3 is also 0. Okay. Hence the optimality is reached at x1 is equal to 4 and x2 is not there, x3 is also not there. So therefore I will write x1 is equal to 4. Now therefore x1 is equal to 4, x2 is not there and x3 is also not there. So x1 is equal to 4, x2 is equal to 0 and x3 is equal to 0. So the objective function is max z is equal to, what is max z? The given equation. I go to the given problem, 5x1 minus 6x2 minus 7x3. 5x1 minus 6x2 minus 7x3. Substitute here. 5 into x1 is 4 minus 6 into 0 minus 7 into 0. 20 minus 0 minus 0 is equal to 20. So therefore maximum z is equal to 20 at x1 is equal to 4 comma x2 is equal to 0 and x3 is equal to 0. This is the required solution. This is how we are going to solve using the simplex method. So the maximum value is 20 at x1 is equal to 4 and x2 is equal to 0 and x3 is also equal to 0. So this is how we are going to solve a given linear programming problem by the simplex method. So the answer is max z is equal to 20 at x1 is equal to 4, x2 is equal to 0 and x3 is also equal to 0. Hope you followed this. So just find out delta j, all the elements in delta j row are positive. If it is positive, then the optimality is reached. If it is not positive, if at all any negative value, identify the least negative and go for the next iteration. Okay, that's regarding the simplex method. Hope you followed. So that's all regarding today's session. Let us meet with a different problem in the next session. Thank you very much.